Okay, let's talk through these. So 3 over 5 plus 1, what does that give us? What do we do to figure that out?
8 over 5.
Yeah, we get 8 over 5. That's right. How did you come up with that?
I put 5 over 5 because I know it divides into 1, and then I added that plus 3 over 5.
Okay, there you go. So rewrite that 1 as 5 over 5 and then add. All right, if we are squaring a fraction, Vinay, what do we get for that? 16 over 49. Excellent. What about number 3? We need common denominator there, right? And so the first fraction becomes what, Chloe?
It's 18 over 63.
Over 63. Excellent. And then the second fraction, Allison? 35 over 63, and I'm writing fast and it's messy. So then we've got to add that. So 8 plus 5 is 13. So what do we get? 53 over 63. Yes? Okay. When we have a square root of something, but then we square it, what happens with that number on the top? It's that number, so it's just 5. But you do have to remember to square that 8, so we get 64. Right, so 5 over 64. The square root of 16 over 25. Jace, what do we get for that?
Plus or minus 4 over 5.
Okay, I like that you're thinking plus or minus. Excellent, because we are going to have to think about whether it should be positive or negative. That's going to depend on which quadrant we're in. So excellent, I'm glad you thought about that. And we can take the square root of 4, we just get 2. Yikes, let me do this. We get 2, and then we still have this square root of 5. What do we do to deal with that? We got to rationalize, right? So we know we're multiplying by the square root of 5 over the square root of 5. So then we get 2 root 5 over 5. And what's the reciprocal of 3?
1/3.
1/3. Excellent. Okay. Questions on any of those?
Is number 6 also plus or minus?
Actually, technically, yes, we should be thinking positive and negative for number 6 also possibly. So, yep, good question and great point. Awesome. Okay. All right. Questions on any of those? Okay, let's go back. I want to go back to these. This is just to kind of help you circle back and be thinking about these identities up here a little bit more. So I need you to think about some alternative forms. So just like we talked about alternative forms for those reciprocal identities, there are some alternative forms for these Pythagorean identities. So let's talk about Sophia's identity first. Her sine squared x plus cosine squared x equals 1. Okay, some alternative forms. So this needs to go on your reference sheet if you want to put it on this page in your notes packet also, but I want you to get this on your reference sheet. Okay, if we want to get sine squared by itself, I want you to think about the fact that we can move or subtract that cosine squared x over to the other side. So I want you to think about the fact that we can say that based on Sophia's identity, an alternative form of that is saying that sine squared x is equal to 1 minus cosine squared x. Okay, and then alternatively, again, if we want to try to get cosine squared x by itself, we could subtract sine squared x, and we get that cosine squared x is 1 minus sine squared x. So just as important, like you need to know Sophia's identity, right? You need to get that memorized. But I need you to think about the fact that it might be that you have to kind of adjust it a little bit for what we are looking at in a problem. So just keep that in mind, okay? All right, that's alternative forms for our Pythagorean, for the first Pythagorean identity. Let's look at alternative forms for the second. We have secant squared basically by itself, but if we wanted to try to get the tangent squared by itself, think about the fact that that would mean we would need to subtract that 1. So tangent squared x would be equal to secant squared x minus 1. So that's an alternative form for Ben's identity, right? The other alternative form, this looks kind of strange, but think about it. We could get the 1 by itself and get the secant and the cosine, the tangent together on the other side. So we could also say that 1 is equal to secant squared x minus tangent squared x. So if at some point you see secant squared x minus tangent squared x, right away you should be able to say, oh, I know from Ben's identity that that is equal to 1. Okay? All right, so extension of Ben's identity is Alice's identity. So let's do the same thing in alternative forms for this 1 plus cotangent squared x equals cosecant squared x. So if we want to get the cotangent squared x by itself, we could subtract 1 and we would have this. We could also subtract the cotangent squared x, so we could have cosecant squared x minus cotangent squared x, and that would just be equal to 1. So those are alternative forms, and like I said, I want those written on your reference sheet. You are going to want them there. If you want to put them on your notes packet also, that's fine, but this needs to be on your reference sheet because that's what you're going to basically keep this as an extension to your brain and your hands for the next little while in math class, to have that reference sheet right there when you are doing anything and everything. It's going to be very helpful. Okay? All right, let's take a look at, there are a few different ways that we are going to use these identities to to work through some different types of problems. We're going to be using some of the math skills that we reviewed here besides our identities. Keep your reference sheet handy because now you don't have that in front of you because you've turned the page, right? The directions here, if you notice, say apply the reciprocal identities. We're going to use quotient identities here also for what it's worth, but if you notice these first examples, it's saying use your reciprocal identities here. All right, if you notice for this first one, it says if the cosine of theta is equal to 3/4, then what's the secant of theta? Guys, what's the relationship between cosine and secant? They are reciprocals of each other. So if cosine of theta is 3/4, then what's secant of theta going to be? 4/3. Right? Does that make sense? We're just flipping it. Okay. This next example takes a little bit more work. Hello. Thank you. Okay. So on this one, if you notice it's saying we know what secant is equal to, and we know what tangent is equal to, and we're supposed to figure out what sine is equal to. So I need you to think about the relationship between tangent and sine for a second. I'm going to focus my attention on that for a second. What do we know about tangent? And the quotient identity for tangent tells us, what do we know? Excellent. Okay, so we know that tangent of x is equal to sine of x over the cosine of x, right? So we're going to plug in what we know into this because we're given information up here. We're told what the tangent of x is equal to.
So it would be 3/4 equals...
Yep, there, keep going, Will. 3/4 equals, we're supposed to figure out what the sine of x is equal to, over, we need to figure out what the cosine of x is equal to.
But isn't secant cosine?
Isn't secant the reciprocal of cosine? Yeah, it sure is. So if we know that the secant of x is equal to 5/4, then think about what that's telling us.
4/5?
That's telling us that the cosine of x is equal to 4/5. All right, so now let's plug that in. I'm going to plug that in color just to kind of help color code things. So 3/4 we were given. That's what tan is equal to. We have to figure out what sine is equal to, but we know what cosine is equal to because we can think reciprocals, right? And so we can write this as 4/5. All right, so now if we're trying to solve for sine in this problem, sine is being divided by something, so what are we going to do in order to solve? Yeah, we've got to multiply. So if we multiply both sides by 4/5, then what do we get for what the sine of x is equal to? Because this divides out, right? What happens with the 4's there? Those divide out and we are left with how much, guys?
15 equals 6, or sine, or 16x.
Hold on, we're multiplying 4/5 times 3/4. So the 4's divide out and we're just left with 3/5. I think you were doing some,
I thought you
Like-
multiply those.
well, if you multiply, then you're going to get 12/20, right? 4 times 3 and then 5 times 4. But then you've got to simplify that, and there's a common factor of 4. And when you divide that out, you're going to get the 3/5. Is that yes, no, kind of, maybe, a little bit? What do you think, Will? Okay. All right, on this next one, it's saying, we're told what the cosecant of beta is equal to. Guys, along the way, if you don't like the beta, if you want to use a b, if you want to use an x, whatever, you do need to have a variable of some kind in there, but if you want to change that, you can. You're going to see a lot more different letters being used. Most of the time, you're going to see a theta rather than an x, but you'll see other variables like alpha and beta and that type of thing also. Well,
So is this one, tan x equals 25/7 divided by 25/24? Oh no, it's a reciprocal. So
we got to think reciprocal, so hold that thought. You're 2 steps ahead of some of us, so I know where you're going and I like it. Okay, we know that tangent of beta, using our identities, we know that tangent is sine of beta over cosine of beta. And then what Will was noticing is that we're told what the cosecant of beta is, and if we know the cosecant, then we can figure out the sine, because we can flip that. And if we're given the secant, we can flip that. Whoops. And that gives us, whoops, I wrote secant, I'm sorry. That's our cosine, right? If secant is 25/24, then our cosine is 24/25. We're just flipping it. Okay, so now we just have to plug those numbers in. So we get our sine. I'm going to color code again to try to help you guys. So our sine, which we decided is 7/25, and then over our cosine, which we decided is 24/25. And we need to do keep it, change it, flip it in order to figure out what's going on there, right? So when we do keep it, change it, flip it, this becomes 25/24. Guys, what happens with the 25s?
they cancel out.
Those divide out, and what are we left with? 7/24. So tangent of beta is equal to 7/24.
You said I could change it to tan of x if I wanted.
If you want to put an x instead of a beta, totally, yes. But please just make sure you are including some variable, some letter there. Okay? Even if you change it to a b instead of a beta, that's fine, but we want some type of letter there. Okay? All right, questions? Okay, take a minute.
Can you keep it here just for a second?
Yep. If you look at the bottom of that page, this should be review. Think all students take calculus. If you need to literally draw that out to help you with this, I need you to be thinking about what quadrants are being represented here by this and deciding whether the values would be positive or negative. Okay. Okay, so for number 1, what quadrant, and then is it positive or negative? Chloe, what'd you get?
Negative.
Okay, what quadrant are we in?
The third.
Careful. If sine is positive but cosine is negative, we are in quadrant 2. All right, for number 2, Kira, what quadrant and what sign?
I said, wait, what quadrant?
Cosecant's negative and cotangent's negative. So that means sine and tangent are both negative. So which quadrant is that?
Quadrant 4.
Yeah, good. Quadrant 4. And so that means that the cosine value is positive. Excellent. Vinay, what about number 3? Let's think about that one for a second. If tangent is positive, but secant, which means cosine also, is negative, then we're in quadrant 3, right? And so then the sine value also has to be negative. Good. Go quickly. All right. From pi to 3 pi over 2, guys, we know that's quadrant 3. So, Caden, what's the sine values are going to be what? Positive or negative?
Positive?
You don't sound too sure about that.
Well, I'm not
In quadrant
thinking about
3, look at your all
Negative.
students take calculus. Okay, it's negative. Okay, and then pi over 2 to pi, that's telling us we're talking quadrant 2. So tangent in quadrant 2 is what? Positive or negative? Do y'all have?
Miss Gallagher emailed me.
I get it.
Quadrant 2, tangent, positive or negative? Shane? Negative. And lastly, from 3 pi over 2 to 2 pi, what quadrant? Jace, what quadrant is that?
3 pi, I thought it would be 3.
Careful, 3 pi over 2
Quadrant 4.
to 2 pi. There you go, quadrant 4. And so cosecant values, in other words, sine, right? Is that positive or negative?
It'd be negative.
That would be negative. Excelente.
Oh, wait. Yeah, because
Okay, questions on those? Okay, onward, thinking caps. Oh dear. And we're gonna do some math. This is good stuff. Okay. So now, if you notice, it says use the fundamental trig identities. So that's not being very specific about which identities, but I will tell you that for these, you are going to be using your Pythagorean identities. So let's review that one more time. Okay. All right, so quadrant 3, so we know sine and cosine and its reciprocals are negative, tangent's positive, and its reciprocal. Okay, we're told what cotangent is equal to. We're told cotangent is 3 over 4. So guess what? That helps us figure out what tangent is also, thankfully, right? So we really only have 4 others that we have to figure out. Okay, let's think about how we can decide or figure out what any of these other trig functions are, right? We're given something about a cotangent. Whose identity, Sophia's or Ben's or Alice's, has something to do with cotangent? It's Alice's, yes. And Alice, your identity says what?
1
equals cosecant squared x. So we're going to use Alice's identity, and we're going to plug in what we know in terms of the math, and then we're going to be able to figure out, in this case, if you notice, we're going to be able to figure out what cosecant is, and guess what? From there, that means we can figure out what sine is too, because we know reciprocals. Okay, so cotangent of x is 3/4. Guys, that means 1 plus cotangent squared. That just means we're going to square this 3/4. And that's going to be what cosecant squared x is equal to. I think now maybe you see why we were reviewing some of those math skills at the beginning of class. I'm going to hold off on writing out that 1 and for just a second. If we square 3/4, the 3 squared gives us 9, the 4 squared gives us 16. So instead of writing that as 1 plus 9/16, I want to write that as 16/16 to help with doing the math computation there, right? And that's what cosecant squared is equal to. So 16 plus 9, we know I'm running out of room. I wrote too big. So we get 25/16 is equal to cosecant squared x. So if that's what cosecant squared x is equal to, then if we take the square root of both sides, then we just get square root of 25 is 5, square root of 16 is 4. Here's where, remember Eden and Jace reminded us when we take a square root, we have to consider the positive or the negative. The beauty of deciding like from the very get-go whether it should be positive or negative is you don't have to worry about that now. But you brought that up, and so I wanted to kind of point out, right? We do have to consider or decide, should it be positive or negative? So our cosecant value is 5/4. Guys, what does that mean sine is equal to? 4/5. Now, we need those negatives in there, but we've already got them written in there. We don't need to worry about those, okay? All right, at this point, we have two options. We already looked at another problem where we were given something about tangent, and we knew a sine, and we could figure out what our cosine was. Actually, I think it was the reverse, and we knew a tangent, and we were given cosine, so we could figure out sine. Okay, so we could use that identity, or I want to use Sophia's identity just to help you guys see and practice with actually using the Pythagorean identities to do that. Because if you notice, we're looking for what the cosine and the secant is. If we know what sine is, if we use Sophia's identity, which says what, Sophia? Plus cosine squared x equals 1. Excellent. Okay, we can plug in what we know sine is equal to into this identity. We can do the math and we can figure out what our cosine is, which then means we can find our secant. So let's do that. So let's plug in our negative 4/5, and we square that, plus cosine squared x is equal to, I want to think about what I want to write my 1 as. If I'm squaring that 4, I get 16. I square that 5, I get 25. So on the right-hand side here, instead of writing this as 1, I want to think of it as, yep, there you go, 25/25. Okay, so now I'm trying to get the cosine by itself. So yikes. So cosine squared x is equal to, if we do 25 minus 16, we get 9/25. And when we take the square root, then we get that the cosine of x is the square root of 9 is 3, the square root of 25 is 5. We've already decided about our signs already, so we don't have to figure that out. We're good to go. So 3/5, and that means secant then is negative 5/3. Nice, huh? Caden's like, yeah, right, lady. Okay. What do you think? Questions? Okay, so we get 5 over 4 is equal to secant squared x. So then that tells us that secant of x is equal to the square root of 5 over 2. Now we need to decide on signs, but we've already decided on that over here. So this is going to be the square root of 5 over 2. So that means cosine, we have to flip that. So we get, wow, I don't know what's going on with my pencil. We get negative 2 over root 5, which we have to rationalize that, don't we? Okay, let's use Eden's idea and use the fact that we know stuff about tangent being sine over cosine instead of using the other Pythagorean identity. Should we do that? Let's try that. So on this one, let's say that we know that tangent of x is equal to sine of x over cosine of x. So let's plug in what we've got. So tangent of x is negative 1/2 is equal to sine of x over negative 2 root 5 over 5. That's not very pretty, but it works. Okay, sine's getting divided by that, so in order to solve, we're going to multiply by that. And if we multiply negative 1 over 2 times negative 2 root 5 over 5, the negatives become positive, right? The 2's divide out, and so then if you look, what we are left with is just root 5 over 5. And then for cosecant, we have to flip that. So this gets weird. Right? If we try to rationalize that, we get 5 root 5 over 5. And what happens there? The 5's divide out, and we're just left with root 5. Okay. All right, hang in there a little bit longer. We're going to do, these are not quite as involved in terms of the amount of work, but we have to kind of do a little bit of puzzling in terms of figuring out how we're going to get to wherever we're going. Okay, so let's take a look at what I mean by that.
Can you zoom?
What do you need, sweetie?
Sure. You're good. I got it.
All right. So on this one, if you notice, we're given a cotangent value, and we're told the cosine is negative, and we just have to figure out what our sine value and our cosine value is. So we want to know that's what sine of theta is equal to and what cosine of theta is equal to. Let's decide on sines right away. It's saying cosine is negative, so I can go ahead and put that in, but let's decide whether sine should be positive or negative. This is saying cotangent, yikes, back up. What's going on there? What did I just do? I'm hitting all kinds of stuff. Cotangent is positive and cosine is negative. So if cotangent is positive, then we're here or here. If cosine's negative, then it has to be down here. So we're in quadrant 3, so that means sine also has to be negative. I don't know what I hit. Oh, wow. Okay. We're given a cotangent. We're given a value for cotangent, and we need to figure out what sine and cosine are. So let's think about the identity that has cotangent in it and see if that's gonna help us, which it will somehow, some way, but we gotta figure out how and if we wanna adjust something somewhere. So Alice, what does your identity say? Because yours is the one with the cotangent in it.
1 plus cotangent squared x equals cosecant squared x.
Okay, so if we use Alice's identity, then we're gonna be able to figure out what cosecant is. How is that gonna help us figure out what sine or cosine is? Sine's the reciprocal of that cosecant. So we can use that identity and get what our cosecant is, and then we take the reciprocal and we're gonna be able to get what we're looking for. Okay, so you have to kind of think about the trail of how one trig function is gonna connect and one identity might connect to get to what we're trying to get to. Does that make sense, I hope? Sure, Mrs. Ireland, clear as mud. Okay. Hopefully it will get clearer. Murky lake water instead of mud.
That'd be like 10.
I'm sorry?
Because cotangent squared, so that'd be 9. Is it a 30? I mean, 2.
Let's see.
wait,
What? Okay, Alice, your identity says what?
1 plus cotangent squared x equals cosecant squared.
Equals cosecant squared x. So I'm using theta. If you want to use x, that's fine. So now this is saying 1 plus 2 squared, which gives us 4, is equal to cosecant squared theta. So if cosecant squared theta is 5, then our cosecant of theta is the square root of 5. And what does that mean then for what we're going to say our sine value is? If we flip that, then that gives us 1 over the square root of 5, which means when we rationalize, we get negative square root of 5 over 5. Okay. From here, we have some options of coming up with what our cosine is. I want you to think about how could we use Ben's identity, which says what?
1 plus tangent x squared equals secant.
Okay, 1 plus tangent squared x equals secant squared x. How could we, from the get-go, have used Ben's identity rather than Alice's identity? And what would be different about that? So think about what Ben's identity says. 1 plus tangent squared theta is equal to secant squared theta. So think about how we're just going to use what we know about Ben's identity, but also what we know about this as a reciprocal. And then that's going to be able to get us to our cosine. Do we see that? Does that make sense? Questions on that? Could you also you could use your cotangent and your sine and do a ratio there as well. But let's go ahead and use Ben's identity. So 1 plus, now you have to be careful here and remember, if cotangent theta is 2, then tangent squared theta is 1 over 2 squared. And that's what secant squared theta is going to be equal to. So there's 1/4 plus, I want to write this as 4 over 4. And just for space sake, I'm going to write this over here. So secant squared theta is 5 over 4, so that means secant of theta is the square root of 5 over 4. And what do we do with that secant value to get cosine? Flip it. So 4 over the square root of 5, and we got to rationalize that. And we've got our two values that we need. It's kind of cool, isn't it, how this works? Okay, we're going to get caught by time, but I want to at least talk to you about how we can get to what we are looking for. Yes, Eliza?
Do you not, would it not be like 5 over 2 because of the force when you like
Oh,
square it?
I'm sorry. Yeah, thank you. Was nobody gonna no one else gonna call me out on that and pick pick up on that? Did no one else see that? Sorry about that. Thank you. Good catch. So root 5 over 2 here, so that means negative 2 root 5 over there as well. Thank you. Sorry about that, guys. Why is my pencil being so weird? Okay, we're going to get caught by the bell, but I want to at least talk through this and to figure out what trig identities you would want to use, okay? If you notice what the worksheet is for homework, it's practice with this. Okay, I need to talk to you about the other part to your homework as well and explain timeline for this stuff in just a second. So we're supposed to find cosecant and cotangent, and we're given tangent. So if we're given tangent, it's really easy to figure out our cotangent. We're just going to take the reciprocal, right? But then we're supposed to find cosecant. Well, if we have a cotangent and we're looking for a cosecant, that's sounding like Alice's identity, isn't it? Right? Okay.